Okay, in this segment, we are going to practice. I have four problems, if you will, that need to be solved. And all we're doing is practicing choosing the correct f value from the table. So in order to do this with me, you're going to need two things. The first one is called in-class exercise. What f value from the table do you need, right? That's the name of the paper. What f value from the table do you need? And the other thing you're going to need is the f table itself, which can be found in SPATS, beginning on page 390 of SPATS. So go ahead and have that handy. Or, it's a little bit messed up, but I did place a PDF copy of the F table as well. So in case you misplaced your stats book or haven't ordered your stats book, which hopefully isn't the case, or if you've burned your stats book in effigy, which also hopefully isn't the case, then you can still access the F table on Blackboard. So here we go. Remember that degrees of freedom between /treat equals k minus 1. The number of groups in our analysis minus 1. It's also the degrees of freedom for the numerator, as you can see. And I think I forgot to mention this earlier. On the table, look at this part right here that I'm running my finger over. So if you will, turn to page 390 or bring up the PDF file, turn it sideways, and look at this right here where I'm moving my finger. That says that's the alpha level, 0.05 light face and 0.01 bold face. We've already established that for the F distribution. Then underneath that it says degrees of freedom for the numerator of F ratio. All right? Degrees of freedom for the numerator of F ratio. Then it's a little hard to read because you need to turn the book upside down then. But I'm now moving my finger over the part I'm going to read next. Degrees of freedom for the denominator of the F ratio. The degrees of freedom for the numerator, k minus 1, the number of groups in our analysis minus 1, is what will dictate the column, when we're turned this way, will dictate the column from which we're going to pull our f value. And then degrees of freedom in the denominator, n sub tot minus k, the total number of cases in our analysis, yes, the total number of cases in our analysis minus the number of groups, will dictate the row. Again, if you have it landscaped the right way, the row from which our f value will come from. Then, whether we're doing a 0.05 test, we choose the light-faced number. If we're doing a 0.01 test, we choose the bold-faced. So we need to know the degrees of freedom for the numerator. That will dictate the column from which the f value, the tabled f value, is going to come. We need to know degrees of freedom denominator. That will dictate the row from which the f value will come. And then if we were asked to do a 0.05 test, we would pull the light-faced value. If we were asked to do a 0.01 test, we would pull the bold-faced value. So let's turn now to this sheet here that I started this segment with. What f value from the table do you need? Let's look at number 1. You've been asked to compare 3 groups simultaneously via a f-test and test the null hypothesis at the 0.05 level. In addition, you are informed that n sub 1 or sample 1 has 5 cases, n sub 2 or sample 2 has 5 cases, and n sub 3, sample 3, has 5 cases. So what would k be for this analysis? K would equal 3, right? Because k is the number of groups in our analysis. What would n sub tot be? Well, n sub tot would be n sub 1 plus n sub 2 plus n sub 3, because we've got 3 groups in here. So 5 plus 5 plus 5 equals 15, right? And then we're asked to find out what the critical value is. Well, first, let's find out, we're asked to test the hypothesis at the 0.05 level. I think we went over that already. So what would degrees of freedom for the numerator, also known as degrees of freedom between /treat, be? I can do that in my head. k minus 1. We've got three groups. You've been asked to compare three groups. K minus 1, 3 minus 1 equals 2. What would the degrees of freedom for the denominator be? That's a little harder, but I can also do that in my head. df within, or error, would be n subtote minus k. N subtote is 15, k is 3, 15 minus 3 is 12. So we've got degrees of freedom numerator of 2, we've got degrees of freedom denominator of 12, and we've been asked to do a 0.05 test. Let's turn to the table. Degrees of freedom numerator, k minus 1, 3 minus 1 is 2. So our F value is going to come from this column right here, the column titled 2, because that's degrees of freedom numerator. Degrees of freedom denominator is 12. So our F value is going to come from this row right here, 12, labeled 12 degrees of freedom, n subtote 15 minus k, 3, 15 minus 3 is 12. And we've been asked to do the test at the 0.05 level, so we are going to observe the light-faced F value. So play along with me. Look at the F table. We've got 2 degrees of freedom in the numerator. We've got 12 degrees of freedom in the denominator, and we need the light-faced F value. So I see a critical F value of 3.88, I believe, if I'm right. Yes, 3.88. What does that mean? That means that if we have a total of 15 cases and 3 groups, and we're testing the null hypothesis at the 0.05 level, that means we could expect a maximum of 3.88 units of between group variance to occur by chance or sampling error alone. All right, I'm going to shut this off, and then we'll do the next 3.